Right, this is an old Commodore PET model 3032, which basically means it's got 32K of memory in it. It's got a 6502 microprocessor. It was sort of classed as a business machine in its day. I've got a set of disk drives for it. They're absolutely massive. So basically, I've had it in a cupboard for a long time, doing nothing. And the last time I tried it, it tripped my earth switch. So I thought I'd have a look at it and see why it was tripping the earth switch and see if it actually still works. The power switch, and I'm guessing this is a fuse, but it's all wobbly. So this is the beast with the lid up. We've got a one big circuit board in here. I'm not quite sure. This is some sort of ROM, I guess. ROM pack. Great big capacitor on there and some regulators. So 7805, that's a 5-volt regulator, I presume, and another 7805 regulator, and the LM340K-12. Maybe that's a, oh wait, no, it says underneath also, it says 7812. I guess that's a 12-volt regulator. This is the microprocessor. These are just sort of peripheral interface adapters, because there's some edge connectors right at the back along there, and I think that's where the disk drive connects into, or we'll say that it might connect into this big connector on the side there. So basically there's a lot of I/O chips. These along here I think are various ROMs, an operating system built into it. Then we've just got a various assortment of just logic chips that join it all together, and I think over here this must be the memory going up here. This is the underside of the CRT monitor. So our loose connector at the back is behind the mains transformer, so I'm going to have to take that out, I think, get to it and have a look at it before I do anything. So this is the actual fuse in the back of the unit, and it's completely blown. The whole Commodore lid hinges up and down, and I'm just resting it on the variac. I'm not sure whether I think it's self-supporting, but I'm not going to chance it just in case it breaks. Right, I've taken the power supply out of the unit, and I've tightened that up a bit, but still doesn't do it very tight. Because it fired the earth trip when I powered it up, and which also took out the mains fuse. I did this years ago, so I thought I'd investigate it now. I just wanted to see why it was doing it, and I was measuring a resistance between, like, this is the mains earth supply, this is the screen in the transformer, and this is a 0 volts in the Commodore PET, but they're all joined together in the chassis, so they're all connected to ground. But I was getting that 0 ohm resistance reading from the chassis and one of these secondary outputs, which I wasn't entirely sure about. So after a little bit of investigating, I realised that I was getting 0 ohms between the secondary winding and the chassis, because there's a centre tapped secondary winding, and the centre tap is connected to the 0 volts on the Commodore main board, and it's also connected to the mains earth, like via the chassis connections. So there's nothing wrong with it, which is good. I don't know why the trip fired in the first place and why the fuse was taken out, but it hasn't done it since. Pins 7 and 8 go to the monitor on the top of the unit. They're about 16 volts AC out of that winding. This winding here and this centre tap winding go to the main circuit board on the PET. Instead of just plugging it straight into the mains, I've powered it up from my variac and tried a few sort of lower voltages into it all first, just to make sure nothing went pop. Looking at the the electronics for the monitor, it's a 9-inch screen in this PET. There's very little on the circuit board compared to something like an old Microvitec monitor, which is much bigger and runs on high voltages. This board is actually powered just from what looks like a 16-volt winding on the main transformer. So the bulk of this board is all quite low voltage stuff. This I think this is an 18-volt regulator. Oh, that's a heat sink. It must get fairly warm. The high voltage bit is over here. This is the what I used to call them EHT triplers. Whether they're still called that, I'm not sure. But the red wire here will have 11,000 volts coming out of it. So that's the kind of scary bit. There's a big sort of power transistor down there, which is, yeah, because it's like a transformer. And there's a big power transistor there, which I guess is the switcher for it. So yeah, so anyway, I've lifted the board up. I've taken these, there's a screw in each corner. Took the screws out and just lifted it up a little bit and looked underneath it with I've got a mirror on a stick. And the soldering underneath all looks pretty good, so I'm not going to take the board out. The big problem with this, because it does appear to work, the monitor, so the problem with it is though the PET is producing lots of random characters all over the screen, which last time I powered it up it didn't do, so I'll need to go and investigate that. So this is the Commodore booted up. It's kind of interesting, some of the characters are correct and some of them aren't. And there's probably, if you hit the enter key multiple times, you just get more and more sort of garbage appearing on the screen. There's a number of chips to generate the display. There's a character ROM. There's a small bit of display memory, and then you've got the main 32K sort of main processor memory. So, but anything that's on the screen ends up in the 2114 4-bit memory chips. There's a pair of these 4-bit chips to give you an 8-bit bus, and they get clocked through to the output. So I'm guessing that might be the fault, but we'll investigate some signals to see what we can find. Right, so the video memory on the Commodore PET is a pair of 2114 memory devices, which are UF7 and UF8, and the data is sort of put into those via this the signal that controls all this system is this chip to the right of them called UF6. So let me look at the circuit. So TV RAM read write is the kind of signal we want to look at. So this is the video memory, the 2114 devices. So we got this 4 bits wide, so there's 2 of them to give you an 8-bit piece of memory. The data is clocked in and out of them via a 244 buffer, which is so data either. So then down here we got the 4116 memory devices, which are this big block of chips along the bottom. These are 16K by 1. So to get an 8-bit 16K by 8 bit of memory, you need 8 of them. And as this is a 32K PET, there's 2 banks of these devices. Well, this is program memory, so this is where like all the memory runs, but then it's kind of shifted in and out of there and through into the video memory via this 244 buffer, which can either sort of, depending on the state of TV RAM read write, defines whether it's writing to the TV RAM or reading it. Then the data from this also goes into the character ROM and then out to the screen. So what I'm looking at here is this signal called TV RAM read write, which, when we look at it on here, it comes off an LS157 chip called UF6, which is the one I've got the orange wires connected up to. So my scope is looking at pin 1, which is the main sort of system clock, which I think is about 1 meg. That's on the scope, that's the lower trace. So the other trace on the scope is looking at pin 6, which is the input of this here. So basically what this chip does, you've got an A and a B input, and depending on the state of this clock, it selects either the A or B input to come out on this output there. So pin 7, the A input is permanently wired up to 5 volts for a 1K resistor. Pin 6 will be changing state, and pin 1, pin 6 may or may not be changing state, but it probably is at some point. And pin 1 sort of clocks, is doing the sort of switching between A and B. So on the scope, we have got the clock at the bottom, and the input to the chip on the top trace. But interestingly, on this one, if I put the scope probe onto the other trace, we've got all these nasty downward spikes all the way along here. They shouldn't. I don't think they should be there really. So this top trace on there is now looking at this signal called TV RAM read write, and those downward spikes, they're not. I don't think they're about a 2-volt spike downwards. So the top of that signal is 5 volts. So the signal's swinging between, the main signal is swinging between the 5-volt power supply and ground. But those 2-volt spikes, you know, they're sort of, they shouldn't affect it, because I think they're just outside the logic level of sort of where it might switch, but I don't like them. So I've bought a couple of 2114 memory chips to replace these, because these are like the most likely problem. I've also ordered a 157 selector chip just to see if that's what the problem is. So I'm going to pull these out and put sockets in and then put the new chips in. Hopefully that will fix the random characters on the screen. Otherwise, if it isn't that, people on the internet say it's these 74153 devices, because they handle the data going into the main system memory, I think, on those ones. So, but the output on those on the scope looks all right, so I'm hoping they're fine. I'm hoping it's the 2114s, and if it isn't either of that lot, it could be one of these 4116 memory devices. Right, so I fitted the new 2114 memory chips in a socket. I haven't changed the chip that's sort of controlling their logic. I don't want to change it unless I need to, because getting these devices out of these old boards, a few risks. I don't really want to. There's always a risk you're going to pull the through-hole plating out, which would be a bit of a disaster. So the scope is still showing a fairly horrible looking signal, but the screen, the actual screen, looks better. I'll take these probes off and shut the lid. Let's turn it on. And there we go, Commodore Basic 31,743 bytes free. Some characters, return key, syntax error. Don't know anything about Commodore Basic, so I might have to investigate that. So as I fitted sockets for the new 2114 memory chips and hadn't wrecked the old ones, taking them out the board, I was able to swap them around and find out which chip actually was the faulty one. And it turned out there was just one that was playing up. The other old one was perfectly fine. So yeah, that seems to be working now. I haven't tested the thing, you know, the Commodore fully. There may be something else that doesn't work on it, but for all intents and purposes, it's working. So, hope you found that interesting. Please subscribe to the channel to support it and be alerted to new videos. Thank you.